Instructor camera. Okay, cool. Good morning.
I think we're on the wrong channel.
I think we're on the wrong channel too. Are y'all taking trig?
No, sir. We're supposed to be in history right now.
Okay.
I was going to say good morning, but goodbye.
Are y'all taking a history class?
Yes.
Alright, there's Sudan. Hi, Sudan. Okay.
Is also here.
Just a second. Sudan.
The three.
Okay. Good morning, everybody. I can see that I have split screen, so I know that the students that are in the history class, are y'all from Tahoka?
Yes, sir.
Okay, they are working on getting y'all switched over to the correct room. So they are working on that right now. So until that happens, you might just enjoy our introduction into trigonometry, even though you probably don't want to take trigonometry. But they'll get you switched over soon. If you are still here in about 5 minutes, I'll go double check. Sudan, how are y'all this morning?
It's cold.
Yes, it is cold. I don't know if it's going to get any warmer anytime soon, but such is the way life is. You know, I was in Santa Fe this past weekend. We did a weekend trip getaway, and it was warmer in Santa Fe than it was in Lubbock, of all places. So, let's see. I think you can. There we go. Zoom in a little bit. You know, y'all have a pretty good. I see a pretty good picture of y'all, but it looks like my picture is terrible. All right, the other class is gone. They're in their right classroom, so we are ready to go. Looking at my roster, you don't have to say if you're here or not. I got Daniel Orega, Grant Dixon, Aubrey Fields, Patrick Herrera, Faith Jennings, and Arissa Moore. I got 6 students on my roster. I see 1, 2, 3, 4 of y'all in there, so Zach, at least name y'all 4. Yeah?
Yes, it did.
Cool. Y'all know where the other 2 students are? Or are they in Sudan?
They're not from Sudan.
Okay. I'm going to find out where they're at. Who are those 2 students that, let me just introduce it. Daniel, are you there? No? Grant, are you there? Right
Yes,
there.
he's here.
Aubrey Fields, right there in front. Patrick, no? So the other 2 must be Faith and Arissa, right? Faith and Arissa, one of y'all 2? And in the back row, lady in the back row, who are you?
Arissa.
Okay, alright, cool. So I'm missing Daniel and Aubrey.
No, Patrick.
Oh,
Patrick and Daniel.
Patrick and Daniel, thank you. I'm going to be right back. I'm going to check on something real quick. First of all, can y'all hear me just fine?
Yes.
All right, awesome. Well, I recognize y'all's 4 names. I know y'all all had me last semester in college algebra. Is that correct? Yeah.
Yes, sir.
Okay. Y'all are a much bigger class then. Y'all have drilled down to 4, so y'all must be the brave souls ready to go on and take trig. Hopefully your facilitator passed out to you a syllabus for this class. I just want to real quickly do a quick introduction, and then I really want to get started with today's lecture. Again, my name is Jared Clopton. The best way to reach me is going to be through my email, which you have right there. Y'all do have a student email account. I really would like y'all to use that. It makes it easy for me to recognize kind of priority emails, and it's easy for me to see who it's coming from. You do need a textbook for this class. Here it is. I don't know if y'all can see it very well. It's the trigonometry textbook. Do y'all have one of those yet?
Yes.
Awesome. Great. I'm going to skip over the course description, the student learning outcomes, the course, well, let's go ahead and talk about the course supplies. You do need a scientific calculator for this class. I'm not going to allow the use of graphing calculators, so whatever you used last semester in my class, I use a TI-30 X2S, $10 calculator at Walmart. As long as it does your trigonometric functions like sine, cosine, tangents, and does the inverse of those functions, you're going to be good. You do need the textbook. Now, when it comes to that 3-ring binder, I'm doing something a little bit different with my on-campus students. This really won't apply to you since y'all are distance learning. So if you switch on over to page 2 of 5 in the syllabus, there's the binder check aspect to this class. I'm not going to be utilizing that part for y'all since y'all are distance learning. But I do encourage you to keep all of your information and resources that we do in class, any sort of handouts that I provide to you, that you keep those in a organized place in a binder, so that way you can go and reference it later. I'm going to be also doing something different with the homework and quizzes this semester. Instead of me receiving homework 3 times a week on Monday, Wednesday, and Friday, what's going to be done is you're going to turn in your homework at the end of the week on Friday only. And at the end of the week, I'm going to be emailing ahead of time to the facilitator a quiz. And so there is going to be a weekly quiz aspect to this class. And it will be based off the homework. And what we'll do is we'll have time, we'll do a brief introduction, close out any topics that we need to cover in class, and then we'll spend the rest of the time on Fridays doing this quiz. And it will be something that will be done during the time that we have in class. And then your facilitator will email me or send to me. Email is just easier, so I'll be contacting your facilitator, but you'll just send with me your quiz and your homework from that week all in one file, and that's how I will be doing some grading. So there will be the homework aspect, which I'll talk about that here in a little bit, but then there will also be the graded quiz portion that we're going to be doing every Friday in class, except for if an exam falls on a Friday. There are going to be 4 exams just like there were last semester. There is the comprehensive final exam. I didn't put it on the syllabus, but I will do the grade replacement like I did last semester, where if your final exam is greater than the lowest exam grade, I will do a grade replacement. I know that being high school students, y'all are involved in lots and lots of activities, and I didn't really have any problem as long as I was aware of a date that you might miss for an exam. The facilitators were always very well at getting in touch with me. Tahoka, welcome. How are y'all doing today? Awesome. I'm glad. I know we had a little bit of issue getting y'all connected. So we are just going over the syllabus. Is it Ben?
Yes, sir.
Yeah. Do y'all have the syllabus yet for? Y'all don't have the syllabus yet, do y'all?
Do not.
Okay. I will get one of those emailed to you as soon as possible, okay? And I will send you with that email some highlights that we're talking about. But we're pretty quickly going to be getting into the lecture today, and you already have access to the notes, and I'll show you where those are here in a little bit. Keeping up with the syllabus. Let's see. Make sure that you're checking Blackboard for references. Email me if you have any questions. And that's about all I have for you today, or at least as far as the syllabus goes. Okay. Let's talk. Oh, one other thing. This is just for your information. I'm really excited about teaching this course. I have one other trig section that I'm teaching on campus. This is my first time for teaching trig, so it's going to be a little bit. I'm going to be kind of learning some things with you as we go. We're going to be, when it comes to memorizing these trigonomic functions and identities, later on, I'm going to be right there with you trying to pound these into my memory, because you're going to need those, especially if you're going to take a college level calculus class later on. So I'm excited about this semester. Let's talk real quickly about Blackboard. I'm going to move on over to my computer screen. So if you have access to a computer real quick, go ahead and log into Blackboard on the South Plains side, and I want us to all look together at Blackboard. Let's see. All right. So when you log into Blackboard, you should see a page that looks something like this, if it'll load up. There we go. All right, so in Blackboard, you should see an opening page like this. It's very, in its developmental stages, but this should be the first page that you see when you open up Blackboard. Everybody see where I'm at? Yes? Alright, if not, let me know. I want everybody to go ahead and click on the folder 1.1 angle and degree measure. And I only got one thing in there right now, and that's what we're going to be doing today. So, click that link, and you should have a document that opens up. Please go ahead and someone, if y'all have access to a printer, go ahead and make copies of these notes, because that's what we're going to fill out today. So, I'll give y'all a little bit of time if y'all need to go ahead and run copies and print those notes out, and that's where we're going to start off today. Or do y'all already have the notes? Sudan? Do y'all have the notes?
Yes.
Awesome. What about Tahoka?
We're printing right now.
Awesome. Great. And this is what we're going to be doing most every single class period, is we're going to be working together to fill out these notes. These notes come directly from the textbook, although the problems are slightly different. So, now that you have those notes printing out, let's go ahead and get ready to go through them real quick. So I'm going to go to my document cam, and here we go. Alright, let me zoom in a little bit. Okay. Angle and degree measure. Now, just real quickly, when you look at the textbook, you can see right here that we're in Chapter 1, Section 1. If you go in and look at the textbook, Chapter 1, Section 1, we are pretty much going to be doing the exact same thing. We're talking about angles right here at first in the notes, and you can see in the textbook we're going to be talking about angles. Then later on we're going to be talking about degree measure of angles, and the same thing, we have degree measure of angles in the textbook. I'm just doing some different problems when we get to the exercises. So, let's go ahead and get started and talk about our topics for today. Alright, so I'm going to go through a couple of definitions to get us going. Array is defined as a point on a line together with all points of the line on one side of that point. So, array differs from a line. A line goes on forever and ever in both directions, but array has a starting point, A, and it goes through a point B, and it also contains all the other points that are on that line. So, on this array, there's, point C, this line keeps on going and going in this direction. There's a point D, and so forth and so forth. This line goes infinitely in one direction, but it certainly has what we call a starting point. So array is not a line. A line is something, I'll just draw that over here. A line is something that does this, that goes through 2 points A and B, but it goes on infinitely in both directions. That's a line. So we're not talking about a line, we're talking about array. An angle is defined as the union of two rays with a common endpoint, aka the vertex. So when we look at this, we have a ray here from A to B, we have a ray here from A to C, and when we bring these two rays together, we have an angle where A is the vertex of this angle, and now we can name this angle either, as it said here, angle CAB. You could also name it, notice how when they name this angle CAB, C CABA, the middle number is our vertex. So another way to name this would be BAC. That would be a perfectly fine way to name this angle. Oftentimes you might just hear us say this is angle A, where again we're defining A as the vertex of this angle, and in this case B and C, and in this case C and B, are just points that the two other rays of the angle go through. Okay, we have some more definitions. Initial side. So when we have an angle composed of two rays, we work in a counterclockwise rotation. So if you look at these two rays and you think about going from counterclockwise or from right to left, we define this as the initial side and this is the terminal side. And you can see right here by this line with the arrow, this little arc, why this is the initial side and this is the terminal side. And we can also name this angle alpha. This is the Greek letter A, alpha, and it's just kind of a nice script A. I kind of draw that as far as my angle alpha. Now, whenever we put an angle inside a circle, so we have the vertex of the angle is also the center of my circle. So the vertex of this angle is also the center of this circle. When we draw this angle inside this circle, there's what's this area called the intercepted arc. It is an arc, it's a part of the circle, and this part of the circle is intercepted by our angle, and we call that the intercepted arc. In section 2 or 3, I can't remember, we're going to be talking about how do we find the length of this intercepted arc, or how do we find the area of this, call it the piece of the circle or the pie, this piece of the pie. How do we find this area depending on whatever this angle is? We're going to be talking about that later on. And then we can also put an angle in standard position where we have a coordinate plane. So we have a coordinate plane where we have our x-axis and our y-axis. We put the vertex of the angle there at the origin, and we have our initial side and then our terminal side of our angle. All right. So, moving on to the degree measure of angles. The measure m of alpha, of an angle alpha, is the amount of rotation from the terminal side to the initial side. So, if I had, for example, here's my, I'm using a circle this time. Here's my initial side and here's my terminal side. If this angle alpha, if we say that the measure of angle alpha is equal to, let's just call it 45 degrees, that means that the angle is rotating 45 degrees from the initial side to the terminal side. So just note that when we see m of alpha, that's just telling you what the measure is of that angle. A circle is divided into 300 equal arcs, and each arc is equal to 1 degree. That's probably common knowledge. If you don't know that, we're going to look at the next page and kind of get a visual sense of what does it mean for a circle to be divided into 300 equal parts. All right, so moving on to page 2 of 4. You see here at the top of this page, we have a picture of a circle, and you can see our coordinate plane where we have our x-axis right here and we have our y-axis right there. And when we start moving around the circle or the coordinate plane, starting here at the x-axis, we define the x-axis going in the positive direction from the origin as, and if we put our circle here, the angle from here to here is defined as 0 degrees. Now, if we add a ray that's going up in this direction, we've now divided the circle into a fourth, and 360 degrees divided by 4 is 90 degrees, so that's why we have 90 degrees up here at the top of our circle. If we continue this process of dividing the angle into fourths, we come over here, and if we take 360 degrees and divide it by 2, because now we've cut the angle into 2 equal parts, we have 180 degrees. And if we continue all the way over here, where our angle is now going all the way over to this terminal side, that's 1/4 right here, that's 2/4, that's 3/4, and of course 3/4 of 360 degrees is 270. So we can begin to divide a circle into 4 equal parts, each equivalent to 90 degrees. So we have 90 degrees if this is our terminal side, our initial side, and if this is our terminal side, we have 90 degrees. Same thing here, if this is our initial side and this is our terminal side, we have 90 degrees in this angle right here. And then we can also divide 360 nicely by 30 degrees. If we take 90 degrees and divide it by 30, or divide it by 3, excuse me, we have 30 degrees, so that's 1/3 of 90. If we add 30 degrees to 30 degrees, we get 60, so that's 2/3 of 90. And then 3 30-degree angles would sum up together to give me 90 degrees. So now we also have not only the, I forgot to do 45, but here we go in just a second. We have 30 degrees, 60 degrees, 30 plus 60 is 90, add another 30, you get 120, 150, 180. So you can see how the multiples of 30 degrees also land on 90 degrees, 180 degrees, and 270 degrees. And then we can also divide 90, or we can divide 360 into 8 equal parts, each of 45 degrees. So take half of 90, you get 45 degrees. And then if you start adding 45 degrees, 0 plus 45 is 45 degrees, plus 45 is 90, plus 45 is 135, plus 45 is 180, and you can see around and around we go. Now, if we wanted to, we could divide the circle up into tenths, we could divide it up into fifths, but at that point, it's kind of becoming unnecessary. We'll talk more about that later on. Let's talk about some other definitions. An acute angle. An acute angle is an angle whose measure is between 0 degrees and 90 degrees. It's an angle whose measure is less than 90, but it's more than 0 degrees. I always remember from high school that an acute angle is a cute little angle. A cute little angle. Anyways, that's what an acute angle is. An obtuse angle is an angle whose measure is between 90 degrees, and 180 degrees. Now notice that when we say is between, it's not equal to 0 and it's not equal to 90. Same thing here for an obtuse angle. It's not equal to 90 degrees and it's not equal to 180 degrees. It's somewhere in between those two measures. And of course an obtuse angle, let me go back up here and draw a little picture. Oftentimes you see an acute angle drawn something like this. Acute little angle. An obtuse angle would be something that looks like this, where you can clearly see that's greater than or 90 degrees. A straight angle is an angle whose measure is exactly 180 degrees. So a straight angle is just a straight line. So when we talk about a straight angle, it is just a straight line comprising of 180 degrees. A right angle is an angle whose measure is exactly, and you probably guessed it, 90 degrees. So when we draw a right angle, it's really not enough to just draw something that looks like a right angle. What we really need to do is we need to add this little box, this little square at the bottom or in between our two rays. This certainly defines that we are dealing with a right angle. Alright, a quadrantal angle. Microsoft Word does not like this word. I had to force it to accept it. But a quadrantal angle is an angle whose measure an angle whose terminal side is on an axis. A quadrantal angle is an angle whose terminal side is on an angle. So when we come back up here to this diagram, 90 degrees, 180 degrees, 270 degrees, and if you keep going around 360 degrees, these are all quadrantal angles. Now, if you kept on going around, so I've moved around all the way to 360 degrees, and if I go another 90 degrees, then I hop all the way up here to 450 degrees. Well, that's also a quadrantal angle. And if you kept on going around another 90 degrees, you would end up here at 540 degrees. That's a quadrantal angle. You can keep going around and around and around and around all you want, and those are quadrantal angles because their terminal side lies on any one of our x or y axes. Finally, our last definition is a coterminal angle, and a coterminal angle is an angle with the same quadrantal angle, or I should say this, angles, plural, angles with the same quadrantal angle. Coterminal angles are angles with the same quadrantal angle. So when we come back up here and look at our picture, if we think about this 90 degrees, 90 degrees and 450 degrees are coterminal. Why? Because they had the same quadrantal angle. Their terminal side is both on the positive part of the y-axis. Alright, I'm going to add this definition to coterminal angles. Their angles differ by multiples of 360 degrees. So if two angles are coterminal, that means that their angles are going to differ by a multiple of 360 degrees. And we have this really nice formula right down here that says that if angles A and B are coterminal, or angles alpha and beta, excuse me. So I'm going to remind us this is alpha and this is beta. Alpha and beta, angles alpha and beta are coterminal if and only if there is an integer k. Now, quick reminder, what are integers? Integers are things like 1, 2, 3, 4, and so on. Or they're things like -1, -2, -3, -4, and so on. Those are integers. Integers are not fractions, they're not parts of numbers, they are the whole counting numbers plus their opposites. So we're ready to get on with talking about some examples. So we're going to move on over to page 3 of 4. And we want to find two positive and two negative angles that are coterminal with 10 degrees. And what we're going to do is we're going to use this formula back here on the back of page 2 that says if angles alpha and beta are coterminal, then measure of angle beta must be equal to the measure of angle alpha plus some multiple of 360. Now, when you're told to do this on your work, make your life really easy. We're going to take 10 degrees and we're going to add it to a multiple of 360. So what's a multiple of 360? Well, 1 times 360 is a multiple. Y'all can't see that, excuse me. 1 times 360 is a multiple of 360. And when you do this math, you're going to take 10 plus 360 and you get 370 degrees. So 370 degrees is coterminal with the angle 10. Now we have to find two positive and then two negative. Well, to find the next positive one, now you don't have to do this, but I like to think easier rather than harder. What's the next multiple of 360? Well, 360 times 2, which is a 720, plus a 10, that's going to be now 730 degrees. So here are your two angles that are positive, that are coterminal with 10 degrees. And it also says to find two negative ones. So what are we going to do? We're going to take that 10 degrees, we're going to add it to some multiple of 360, but we have to be thinking that ultimately our end result must be negative. So what integer could we put right here? How about -1? Because now, -1 times 360 is a negative 360 plus a positive 10, that's negative 350 degrees. There's our first negative angle that is coterminal to 10 degrees. And we could also do the same thing, very similar. Multiply 360 by a -2. So negative 2 times 360 is a negative 720 plus the 10. That's negative 710 degrees. All right. Due to time, I'm gonna kind of move on a little bit quicker. For the next example, you want to find two positive and two negative angles that are coterminal with negative 25 degrees. So we're going to take the negative 25 degrees, and we're going to add to that 1 times the 360 degrees, and we're going to do our mathematics, and we get the following 335 degrees. And you would do the exact same thing, except now you're going to multiply 360 by a multiple of 2, and you'll get your second positive coterminal angle to negative 25 degrees. Same thing, we want to find two negatives and two positive angles that are coterminal. So we have negative 25 degrees plus a negative 1 times 360 degrees. We are going to do our quick calculation, and we get a negative 385 degrees. And that gives me my first negative angle that is coterminal to negative 25 degrees. And we're going to do the same thing, negative 25 plus a negative 2 times 360. That's going to give me a negative 745 degrees. Alright, example 2. Ask the question, to determine whether or not 20 degrees and 380 degrees are coterminal. The real question here is this: do these differ by a multiple of 360? Is the difference between 20 degrees and 380 degrees a multiple of 360? Well, it doesn't take much work to verify that yes, they are. 380 degrees minus 20 degrees is 360. 360 is a multiple of 360. So yes, we can already determine that these two angles are coterminal. But how do we do this mathematically? Well, we're going to set it up using our formula that we have back here on the bottom of page 2. The question is this: is 20 plus some k times 360 equal to 380? Well, remember, k has to be an integer. Well, what we need to do is we need to solve this equation. So I'm going to start off by subtracting 20 on both sides. So that gives me k times 360 is equal to 360. Then I want to divide both sides by my 360, and that's going to give me that k is equal to 1, which, what is 1? It's an integer. So there's further proof that yes, indeed, these two angles are coterminal, because when we solved this equation, k became an integer. Well, what about this problem? Are the angles 272 and negative 952 coterminal? Well, let's find out. 272 plus some integer k times 360 better be equal to my negative 952. Alright, and we're going to go through and solve this equation. So, subtracting 272 on both sides gives me the following: 360k is equal to a negative 1,224. If I go through and divide both sides by 360, I get that k is equal to negative 3.4. So you need to make sure that you're verifying my mathematics as we're going along, but you should get a negative 3.4, and is negative 3.4 an integer? The answer is no, not an integer. So therefore, these two angles are not coterminal. All right. What time is it? 47. I'm going to let you go ahead and tackle on your own example 3. And we're going to pick up right here with the understanding of minutes and seconds on Friday. So, to close out class with the final minutes that are remaining, I'm going to be sending out either to Tohoka the syllabus, or I'm going to put it on Blackboard. As a reminder, I will be picking up homework at the end of the week, so they will be sent to me at the end of the week along with the quiz that will be given at the end of the week. Now, when it comes to doing the homework, and I really had a great response from y'all last semester, even though I didn't get around to grading much of it, but the homework, as far as the way that you were doing it, was very good. You were showing me your work, the processes that you were going through to solve these problems. That's what I want to see here. So things like determining whether or not two angles are coterminal. Go through the mathematics that we're going through right here on the notes as well to make these decisions. Show me your work, and that will be very helpful to you when it comes to doing the quizzes and exams that we are going to have throughout the semester. Okay. With that being said, I will see y'all on Friday. If you have any questions, please let me know. You have my email address, and I'll be working to update Blackboard throughout the week so that when we come in on Friday, things will we'll have some more information on there. So just be looking out on Blackboard. All right. Have a great day.